fashion. So this is when the velocity, see, velocity is the slope of ST curve. Now first we say that for this much part the velocity is increasing, so the slope is positive and it is increasing. So so here the slope is positive and it is increasing. But as we move to the next part, the velocity is still positive, but definitely the slope is reducing. So up to this level, velocity is positive and it is increasing. The slope is increasing. And for the second part of this, I can say that velocity is positive, but the slope is reducing. Continuously, the slope is reducing. So it will be perfect to say that this is the correct answer because this matches with the description of our graph. In this, it is saying that the displacement is reducing and sometime after the body is reaching the same destination again because the displacement has become zero, and that is not possible because the velocity is not negative. So this is also wrong. And in D part, the slope is positive everywhere, but first it is reducing and then the slope is increasing. So it means that the first the velocity is reducing and then the velocity is increasing, and the velocity is positive, it does not change the direction, but hence this answer will also be wrong. So B is the correct answer for us. All the best. Okay, in this question, a ball is tossed vertically upwards with a speed of 5 meter per second. After how many seconds will the ball return to its initial position? So it means like there is this ball and it is thrown upwards with a speed of 5 meter per second. And after how much time will the ball reach back again? So there is in this question, like there are many formulas which we can directly apply and we can find what will be the answer. And I know that the formula is like 2u by g, if I'm not wrong. Might be, let me see, 2 into 5 divided by 10. So it is 1 second. And yes, the answer is 1 second. Okay. So that is okay. But from where this formula comes, now that's the big thing. So let me tell you this. Okay. Now there is this formula that S is equal to ut plus half at square, very famous formula in kinematics. But when we apply this in the motion under gravity questions, so what we do is we take one direction as a positive, another as negative. So we can take gravity as negative and the velocity as positive because we have actually thrown it upwards. And we will apply the formula. This is a vector equation. We must be knowing this. So we need to understand where the origin is. Origin is taken to be the initial position. So this point is O. So all the distances will be measured with respect to O. So from O, if we see the body is going upward and upward is positive, I'm just now putting the value. See, so the body from O, it goes to A, and from A, it goes to B. So in the total journey, the ball is coming back to the same location as the earlier. So what is the total displacement of the body in the time t? 0, because it has reached the same point. So we will say that the displacement is 0. Velocity in the upward direction, so it is 5, and we need to find t. So this plus half. And what will be the acceleration? It is g, which can be taken as 10, but it will be downwards, so it will be minus 10 into t square. We need to solve this. So 5t minus 5t square, 0. T will be taken out, and okay, 5t will be taken common, sorry. Or I can do it like this. T is equal to 1 second. Although we know that the formula that is to be used for this kind of a case is T is equal to 2u by g. That is the general formula. It can be applied everywhere. Okay. So this is it. All the best. Bye. Okay. So in this question, A projectile is fired horizontally from the top of a cliff. The projectile hits the ground 4 seconds later at a distance 2 kilometers from the base of the cliff. So from the base of the cliff, the body has reached 2 kilometers away and the time taken was 4 seconds. What is the height of the cliff? So the diagram for the same will look somewhat like this. Like let us say this is the projectile and we have kicked a ball or it's a missile, whatever you can call. So it's a projectile that is fired horizontally and it is bound to go like this. So this position is basically 2 kilometers away from the foot of the cliff. Okay, and the time taken was 4 seconds. And time taken is 4 seconds. Now in this, uh, so we know that the formula for the time period is always root of 2h by g. And from there we can find the range is not actually required in this question. So the time period will be 4 second. Uh, 2h by g can be taken as 10, 16, 2h by 10, 8. It will be 80 meters. Yes. So there is the answer. So in this question, as we can see that the data that is given to us is more than what is actually required. So it is done generally to confuse the student. So don't get confused. Range is a completely different thing. And as per as the time of the motion is concerned, the time of flight is concerned, it is based only and only on the one thing. What is the height of the building? It is independent of the velocity u. We know that the formula for time period is root of 2h by g. You can derive it by concentrating on its vertical motion, and we can say that the u is 0 for the vertical motion, and then s is equal to ut plus half gt square. This will be taken as 0. S will be plus h half into gt square, and from here we find the formula that I have used here, root of 2h by g. Okay, so this is how we derive it, and I think the concept should be 100% clear now. All the best. Bye. Okay, so a tennis ball is released from rest at height h above the ground. At each bounce, 50% of its kinetic energy is lost to its surroundings. What is the height reached by ball after its second bounce? Okay, after its second bounce, and that is the most important thing. Okay, so in each bounce, 50% of the energy is lost. So basically, this is the ball, and it goes down, and after that, 50% of the energy is lost. So let us say the potential energy initially it was mgh, and now the kinetic energy is half mv square, and whatsoever 50% is lost. So it means that 50% of the total energy is lost because as it moves from the position A to position B, the all of the energy which is potential energy is converted into kinetic energy first of all. So 50% of the kinetic energy means 50% of the whatever total energy the body was having, it has been lost. So now it is remaining only 50%. So obviously with this much of the energy it would be going at half of the height. Like why? Because earlier the energy is mgh, but after the bounce, it is mgh by 2. The half of the energy is left with the body. So the mass does not change, the gravity does not change, so height has to change. So it means the body will go up to h by 2. Now it goes for the second bounce and it again moves up. And 50% of whatever the energy it was having, that has been lost. So the 50% of this, it will be mgh by 4, half of the half. So mgh by 4. It means now it will again attain the height which is h by 4, which is h by 4. So H is the total energy, it is H by 2, and then it is H by 4 further. So your answer will be H by 4, answer will be B. So you are left only with 20%, 25% of the energy. 100% energy, in this it is having 50%, in this 25% of the energy. That is why it is H by 4. All the best. Bye. Okay, so the graph shows the variation of the acceleration a of an object with time t. What is the change in speed as shown by the graph? We need to find the change in speed. Okay, so there is a concept here. The concept is, let us say there are three graphs we have. Now, this is displacement versus time, this is velocity versus time, and if this is acceleration versus time, so there is a connection between all these three things. Let us say there is a body which is moving with an acceleration, whether uniform or whether non-uniform. There will be a graph of acceleration versus time. So with respect to that, we can create the graph of velocity with respect to time. We can create the graph of displacement with respect to time for the same body. And there is a relation between all these three graphs. Now, what is that? Uh, when we go downwards, we find the slope of the curve, and when we go upwards, we find the area under the curve. So the concept is the area of VT curve will give you displacement. This is what I want to say. This is what I want to uh, tell. So, and the area of acceleration time curve, now we are moving upwards and we need to find the area. So area of the acceleration time will give you the velocity at that particular time. Although it is area, the unit is not meter square. Be very careful about that because this is physics, it's not maths. The area is not meter square every time. It depends upon the x-axis and y-axis. So every time we have to calculate the dimension of the area that we are calculating according to the graph, and whichsoever is the physical quantity with that kind of that unit, that is the physical quantity that we are able to find. So this is the area. So according to our question, we need to find the velocity, area, and acceleration and time curve is given. So the area of AT curve will be equal to velocity. So what is the area? Half into base into acceleration, base into height. So this is 6. So your answer will be 36 meter per second. So your answer is C. There's no doubt about that. But there is another thing that I was telling you in the question earlier, in the theory earlier, like if we are going downwards, we find the slope. Now, what is that? Slope means that the slope of ST curve, now we are moving downwards, it will give you velocity, the instantaneous velocity at that time, and the slope of VT curve will give you the acceleration, the instantaneous acceleration. Okay, so always remember, along with these, like these three graphs, if we want to go downwards, like if the displacement time is given and the question is about the velocity, or the velocity time is given, the question is about acceleration, you need to find slope. If it is the other way around, acceleration time graph is given and they are asking velocity, you need to find the area. If they have given velocity time and they're asking question about displacement, you need to find the area of VT curve. I think with this, your concepts will be clear. Okay, then, all the best. Bye. Okay, the variation of the displacement of an object with the time is shown on a graph. So the graph is not given in the question. First of all, it's just general question that there is a graph between the displacement and time. What does the area under the graph represents? So the area under the graph. Okay, so there is this graph. They say this is displacement and this is time, and there is this graph randomly chosen. So what is the area under the graph? So my dear students, there is a concept in this question. First of all, the concept is that in the graph, when we are drawing these kind of graphs, there are two things, like the area under the curve and another is the slope of the curve. Okay, so both of the things, from the mathematics point of view, it is just area and the slope, but in the physics point of view, it's much more than that. It depends upon your x-axis and on y-axis. For example, if I say that there is a this quantity displacement and time, and if we talk about the slope of curve, so what will be the units of that? It will be displacement divided by time. So it will become meter per second. So we know that the slope of displacement time curve should give us velocity. For mathematics, it's just slope, but in physics, there are so many of the things. Now, this is the slope. Now, as per the area is concerned, we can take one example more for the slope. Let us say there is a graph between the velocity and time. Again, you will see the units. We will always see the units. So the slope here, it will be meter per second divided by second. So it will become meter per second square. So it means that if there is a graph, a velocity and time, and we find the slope of it, the slope of that graph will give us the acceleration, the instantaneous acceleration happening at the instant. So the slope of VT curve is this. But if I talk about the area of the curve, let us say area under the curve. So we have to find the physical quantity that we are creating with the help of units and dimensions here. So in this case, let us say in the second case, what is the area under the curve? Like this, let us say we find this area. So it will be velocity multiplied by time. So what are the units? Meter per second multiplied by second. Second and second cancels and it becomes meter. So meter belongs to displacement. So we can say that the area under VT curve is displacement. So the question is, what is the area under displacement time curve? Now that is a different thing. So we will again follow the units and dimension method. So to find the area, it will be the displacement multiply by time meter second. Do we have any physical quantity with the units of meter second? Well, in kinematics, there is not. There is no physical quantity that we know having this dimension. So we will say that no physical quantity is represented by the area under the curve in the displacement time graph. So our answer is no physical quantity. Okay. So all the best. Bye. Okay, an object is thrown upwards. The graph shows the variation of time t with time t of the velocity v of the object. Okay, and there's the graph. What is the total displacement at a time of 1.5 seconds measured from the point of release? And the object is thrown upwards, so the velocity will be reducing if it is thrown upwards. So definitely the velocity was 5 when it was thrown up, and when it reaches the highest point, the velocity becomes 0, and after that it starts falling downwards, and then immediately it rebounds. The possibility is that the body was gone up, it struck the bottom once again, and then it rebound like this, like this. So at this point it has rebound and it moves up to 1.5. It again reaches the same height because the loss of the energy is not included here. So we can say that body will rebound up to the same height, up to the same level, because the loss of energy has not taken place. So now in this case, this is a very beautiful question, I would say, because there is a very good concept involved in this. The concept is the area of a VT curve gives you the displacement, but because the displacement and the velocity, they are vectors, so negative velocity will give you the negative area. So to find the total displacement, we will find the total area under the curve, and the total area under the curve, we need to first find this area, we need to find this area, and then we need to find this area. Simple. And that will be the displacement. Now the area of this triangle, that will be, let us say area 1, it will be half into base, that is 0.5, into height, which is 5, and the area 2 will be again the same, but this area this will be positive, and this is going to be negative. So when we add all these three terms, these both of the areas will cancel each other. Okay, so this area and this area, they cancel each other, because when we add them, it adds up like that only. So we are left only with the third term. So A3 will be positive, it will be half into base into height. So this is coming out to be 5 by 4, which is 1.25 meter. 1.25 meters. So our answer is B. I hope you understand. Our total displacement, it will be given by area 1 plus area 2 plus area 3. Both of these areas cancel each other out. It will be remaining only, that is A3. Okay then, all the best. Bye. Okay, the question is, an object is released from a stationary hot air balloon at the height h above the ground. An identical object is released at height h above the ground from another balloon that is rising at the constant speed, that is rising up. So there are two balloons. One stone is thrown from one balloon which is stationary, but the other balloon is rising up. So it is having certain velocity. It is having certain initial velocity. So the stone on the second balloon will be having some initial velocity in the upward direction. Okay, resistance is negligible. What does not increase for the object released from the rising balloon? Okay, so out of the following options like A, B, C, D, which is the physical quantity which is basically same in both of the cases, which does not increase or might be decrease also? But anyways, let us see. To be very clear about the question, there are two balloons now. Let us say. So there is a stone here, and this is a stationary balloon, and it is dropped from this. So obviously the initial velocity here will be equal to 0. But in the second case, the balloon is rising up with certain velocity, let us say u, and there is also a stone here. Let us say there is this stone. So this stone is having an upward velocity, it is u now, and now it is thrown up, like uh, it is thrown up with the velocity u. So it will first go upside, and then it will reach the zenith point, and then it will fall to the ground. So this is the complete description of this thing. So what does not change? Let us see. The distance through which it falls, well, definitely it will change. So this option is wrong, because it will go straight forward downwards, but it will go up. So distance is different. Time taken for it to reach the ground, well, definitely the time will also increase, because this is having more distance, so time will increase. The speed with which it reaches the ground, well, that is also bound to increase. The velocity with which it is moving up, so as a characteristic of the projectile motion, you can say, or characteristic of the motion under gravity, the body, when it reaches back to this position, it will be moving down with the velocity u only. This is a characteristic of this kind of a motion, that at all the points which are horizontal at the same level, they would be having the magnitude of the velocity will be same for both of the points. One velocity will be in upward direction, another will be in downward direction, but the magnitude will be same. So this will definitely reach here with a higher velocity, there is no doubt, and the speed. So what is not different? It's acceleration. Well, exactly, this answer is absolutely correct, because both of the bodies are getting accelerated with the acceleration due to gravity, that is g, which is 9.8 meter per second square. So our answer will be definitely D. All the best. Okay, so in this question, let us see. A parachute of total mass 70 kg is falling vertically through the air at a constant speed of 8 meter per second. What is the total upward force acting on the parachute? So, according to the question, whenever a body is under free fall, try to understand, it will always be acted upon by the force accelerated due to the weight, and it is known as acceleration due to gravity. So the velocity of the body should increase, but it is that, and it keeps on moving with the velocity that is 8 meter per second. It only means net, the net force that is acting on the body, to zero. It means if there is this body and this body is having a downward force acting on it, that is weight, so an equal and opposite force, we might call it like drag force or viscous force, which is general resistance. But in this question we are not neglecting it, and obviously there is an upward force which is trying to act against the weight, and so we can say that the body is not acted upon by any force because F net is coming out to be equal to zero. Under that condition only, it can travel at uniform velocity at a constant speed. So